Okay, so picture this. Right now, somewhere in India, tens of thousands of students are absolutely glued to their screens. But this isn't some blockbuster movie premiere. No, this is a live event that could literally define their future. It's the final intense push before one of the most important exams of their entire lives.
And that's the voice of their coach, an online physics tutor known as Prem Sir, kicking off a live session that's going to last for hours. You can just feel the energy. The stakes are unbelievably high. The chat is just flying by. This is way more than just studying. It's like a digital training camp for your brain.
They actually call this a MAHA marathon, a great marathon. And get this is just day 3 of a massive physics review. And you gotta ask yourself, what kind of exam requires this almost athletic level of preparation? Well, the reason for all this intensity isn't just about the sheer volume of stuff to learn. It's because the whole game has changed. The very nature of the exam is fundamentally different now. The old way of doing things, just memorizing formulas and definitions, that's just not going to cut it anymore. So let's dive into what's really at the heart of this whole revolution. It all boils down to a new type of question that's totally changing how students in India are being tested, and not just in physics, but across pretty much all subjects. They're called competency-based questions, or CBQs for short. And the goal here is pretty simple. It's not to test if you can just recite a law from a textbook. The real test is to see if you can actually use that law to analyze a situation, to think critically, and to solve a problem you've never ever seen before. This slide just lays it out perfectly. Look on the left, that's the old style, state Newton's third law. Simple recall. But on the right, you see the competency question. Analyze a rocket launch using Newton's laws. See the difference? Now you have to apply the concept. It's the difference between knowing a fact and knowing what to do with that fact. And this isn't just some minor tweak to the exam either. These new, more difficult questions now make up a staggering 30 to 40% of the entire exam. I mean, that's a massive shift, and it has huge implications for how millions of students have to prepare. All right, so what do these questions actually look like in the wild? Let's decode a few examples. These are pulled directly from the official 2024 Class 10 physics exam paper. So first up, we've got a classic mechanics problem, but with a twist. The question asks you to calculate the work done moving a block up this ramp. But here's the catch. Notice you're given a few different lengths. This is not a simple plug the numbers into the formula problem. You have to really understand the physics of what's happening. Okay, next up, a question about equilibrium. But instead of giving you a simple, straight ruler, they give you this weird, non-uniform beam. This tests a much, much deeper grasp of things like moments and center of gravity. It goes way beyond a formula you just memorized. And here's one from optics. Students aren't just asked for the definition of refraction. No, they have to predict exactly how this glass block is going to change the path of light and where the new focal point will be. It's like a visual puzzle that forces you to apply the principles. So to really get a feel for the kind of thinking this requires, let's break one of these problems down together. We're going to see how it's less about doing complicated math and a lot more about thinking like a physicist to solve a puzzle. So we're going back to that first problem, the one with the inclined plane. It looks pretty straightforward, right? But there's a really clever trap hidden here in plain sight, and it's designed specifically to catch students who are just banking on memorization. So here it is, the heart of the puzzle. You have a force F pulling this block along the ramp. And you've got 3 different lengths to choose from. The vertical height is 3 meters, the horizontal base is 4 meters, and the length of the ramp itself is 5 meters. So which one is the right one to use to calculate the work done? Okay, the key here is to just ignore all the extra numbers for a second and go back to the most fundamental definition. So step 1, what is work? It's force times displacement, but, and this is the important part, it's the displacement in the direction of the force. Step 2, look at the force. It's pulling along the ramp. So step 3, that means the displacement we care about must also be along the ramp, and that length is 5 meters. So step 4, that's our answer. The 3 and the 4, they're just there to distract you. See, the really crucial thing here is that solving this requires a thought process. It's about understanding the why behind the formula, not just memorizing the what. And that right there is the whole essence of a competency-based question. So this brings us to the really big question. Why? Why make this huge change? Why shift to a system that needs these intense MAHA marathons? Well, the answer goes way beyond just one physics exam. It's about a massive shift in the whole philosophy of education. You see, the long-term goal is to pivot the entire education system away from just memorizing facts. The focus now is on developing the critical thinking skills students need for those hyper-competitive university entrance exams. And, maybe more importantly, for equipping this generation with the problem-solving abilities they're going to need for any real-world challenge life throws at them.
I mean, this is a massive educational experiment, and it's happening right now, in real time. And it leaves us with one final thought. As testing keeps evolving all over the world, are we getting any better at designing exams that measure not just what students know, but what they can actually do with that knowledge? Are we truly building the problem solvers of tomorrow?